Hello, everybody. Good morning, good afternoon, or good evening, wherever you're located, and welcome to today's webinar. We have very interesting topic and awesome speakers, so looking forward to it. You're going to learn today how to replicate data from other databases to CrateDB, Debezium, and Apache Kafka. And for today, we have as a very special speaker, Danica Fine. Hello, Danica. Welcome. Myself, Maria, working at CrateDB Developer Allocate, and my colleague Ernan, working as a senior solution engineer at CrateDB as well. So I'm today based in Frankfurt. Danica, you're based in San Francisco, right? And Ernan is based in early morning, yes. And Ernan is based in UK. Would be also very nice to learn where you're based today. And yeah, looking forward to learn more about this. But before we start, let's align on a couple of rules in today's webinar. So like if you have any question at any point of time, please use the Q&A function in Zoom. We will answer them at the very end, and we will make sure that all the questions are addressed. At the very end of the webinar, you will receive a feedback survey. Please fill it out and help us be better next time. So our agenda for today looks simple, but it's full of very interesting content. First, Danica will give us a short intro about Apache Kafka. Then we will talk a bit about CrateDB and Debezium and how you can turn your database into event streams. And then Ernan will deep dive into demo, and he will show how you can replicate your data from SQL Server instance to CrateDB without writing any custom code. And then we are going to the Q&A session. So Danica, welcome again. The floor is yours. Thanks a lot for being with us today. And yeah, looking forward to learning more about Apache Kafka.
Absolutely. Thank you so much. I'm just going to share screen, fingers crossed. All right, hopefully everybody can see that. Wonderful. So as was stated in the agenda, I'm here to just give you a brief introduction to Apache Kafka, just to make sure that we're all level set and we all understand what we're getting ourselves into today. All right, so for those of you who haven't heard of Kafka, it is a distributed event streaming platform. And I can end right there. That's pretty much three meaningful words there that you could use to describe it. But I really want to dive into each of those words individually to give you a better idea of what this technology is and what it can do for you. All right. So first and foremost, it is a streaming platform, right? And so you may have noticed over the last decade or so, definitely, that we've been sort of undergoing a paradigm shift in how we deal with our data. And not only that, how we process it, how we store it, how we move it, anything that we do with data, it's sort of shifting, right? We're moving from slower, maybe batch-focused systems, and we're moving towards this idea of stream processing. So instead of waiting minutes, hours, days, months, I don't know, to consume data in batches and then process over those batches, we're instead building systems that can react to smaller amounts of data and produce actionable results more quickly, ideally in real time, as close to when that data is created as possible. So that whole thing is this is stream processing. And there are a lot of different technologies that can do stream processing for you, help you build a streaming system. Kafka is just one of them, right? But there are many benefits to using these technologies, right? We can actually increase the accuracy of our data and our results. We could build a more reactive system. And then in the case of Kafka especially, we can actually increase the resiliency of our overall system, right? We're building a more loosely coupled system with Kafka in the middle of it. And so Kafka is a platform that helps you do stream processing. But more than that, it can serve as a messaging system. It can serve as a persistent storage layer and a processing layer, if you'd like. All right, but more than that, Kafka is not just a streaming platform, it is an event platform. And I think this is one of the most important things that folks need to internalize when they're starting to use Kafka at the beginning. To use it successfully, you have to understand events. And you need to start thinking in events. But this isn't me asking you to rewire your brain, because as humans, as programmers, as users, we already know how to do this, okay? We already know how to submit forms online. We know how to look at application logs to debug. We know how to react to notifications on our phones. These are all events. So just be a little more cognizant of that fact. So those are examples of events, but what is an event really? Well, it's just a piece of information that describes something that has happened. Okay, it's pretty simple. It's nothing, world shattering, right? It's pretty basic. So to describe something that's happened, we need to know when that thing happened. That's really important. We need to know the timestamp, and then who or what was involved. All right. So a key component of events is that they're meant to be immutable. Okay, they've described things that have already happened. All right. And so it's just an unfortunate fact of life. So if I had events describing, say, the state of my bank account, right? If I withdraw money from my bank account, great, that is an event. If I withdraw 40 euro from my bank account yesterday at 2:30, great, that's an event. But I can't go back and delete that event, right? I could sort of undo it by going back to the bank today and redepositing that 40 euro, but I can't actually delete that event that happened, okay? What we're going to be doing instead of deleting information is adding more events to a timeline of immutable facts that describe a system, or in this case, my bank account, right? So Kafka is an event-based streaming system, and based on those two things, you might start to see how this can be valuable, right? Where we have these immutable facts that are flowing through our system in real time, and we're able to build more applications on top of that to react to those facts, those golden source of truth, right? And I think that's pretty cool. You're going to open up a lot of different use cases for that. But to see how Kafka actually helps you do this, we got to look a little bit more into Kafka architecture. And it's a distributed platform, right? So the primary unit of storage in Kafka is a Kafka topic, and that's just a data set consisting of events. We get data into Kafka using clients called producers. And later, once data is in there, we want to get it back out, we use separate clients called consumers. Right? We can have as many of these producers and consumers as we want, and they're completely decoupled from one another. All right. So these topics are actually broken down into smaller components called partitions. And the reason that we do this is that we want to be able to spread the data set across different nodes in our Kafka cluster. Okay. And the Kafka cluster, just not going into too many details here. So this would be an example of a simple cluster where we have 3 topics and they're broken down into some number of partitions. And so what's great about this is that, what's not ideal about this first is that if one of these brokers goes down, we might lose some of our data. But because we have these smaller data sets across our brokers, we can actually replicate the data at the partition level. So looking at a single topic here with 3 partitions, in this case, we have our data spread as evenly as possible across this Kafka cluster. And so when I'm writing data as a producer to say broker 0 to partition 0, we're going to write that data first to partition 0, and then we're going to replicate it synchronously to brokers 1 and 2. So that in this case, if any nodes go down, we don't actually lose any of our data. All right, that was a very, very high level intro to the architecture of Kafka, but I think it's worthwhile to just keep in the back of your mind and just know the cool things that are going on behind the scenes for you. So that was Kafka in a nutshell. It's a distributed event streaming platform, but why do you care? Why should you bother using it? Well, what's cool is that at the surface level, you can use Kafka to build real-time applications. But taking it a little bit deeper, we can also use it as something that we like to call at Confluent a central nervous system. Right, so in this case, we're going to take many data sources and we're going to put them into Kafka. Okay, these could be application logs. This could be anything from devices, from your mainframes, from databases that already exist, and we're going to put them into Kafka and unify them in one place. So we're really lowering the bar to get access to data across your organizations, across your system, and then you can start to do cool things and maybe unlock different insights from this data and start using them for different use cases, which is interesting. But how do we get a lot of this data into Kafka? Well, that's where something called Kafka Connect comes in, okay? So Connect is a really awesome framework that works alongside Kafka that bridges the gap between Kafka and external data sources and sinks. So I have couple subset of examples on the right here that you can see that we have connectors built for. So a lot of these are databases, data sinks that you might be familiar with. And so what's cool is that it's configuration driven. You don't have to write any code to launch a lot of these connectors. And this is actually what we're going to get into today. So I will now hand it over so that we can start looking into Debezium, which is one of the source connectors that we can take advantage of in the connector ecosystem. So thank you.
Thanks a lot. I've already learned a lot. So yes, today we are going to share also the main point of Debezium and to talk more about the tool. But before we get into Debezium, I would just like to introduce shortly CrateDB. I really hope that everybody in the call is familiar with the CrateDB, and it's a distributed SQL database. It is open source and built on top of Apache Lucene. This allows you to run very fast queries across billions of records in very short period. And CrateDB also leverages something called columnar storage and parallel execution that allow you to do fast aggregations, grouping, sorting, and all these database operations that you love to see being very performant. You don't need to learn any proprietary language to work with CrateDB. You can rely on a SQL, and CrateDB implements Postgres protocol that makes it compatible with a lot of tools, including Kafka, which we are going to see how you can connect to Kafka Connect later on. And in CrateDB, you can more or less store and analyze all types of data, including relational data, time series data, nested objects or more complex objects, geodata, and you can also use it for full text search. Currently, it's available as on-premise, but you can also have hybrid and cloud deployment, which we will also mention at the end of this webinar. CrateDB has a shared nothing architecture, which allows you to scale it to hundreds of nodes that can analyze petabytes of data. And because it's able to handle these large data sets, you can use it for analyzing also historical data. So with CrateDB, there is not really a need to do some sort of downsampling if you want to do some advanced analysis on a lot of data. And finally, it's important to mention that CrateDB has built-in high availability and automatic failover features. So saying that CrateDB is Postgres compatible means that CrateDB can work with the many different tools out there. Today, we are going to see how it works with Kafka and Debezium. So I would now take a few minutes, just a few minutes, to give a first intro to what Debezium is and why it's important platform in general. So Debezium is a platform that actually implements something called change data capture. So it's able to capture and stream real-time modifications that are made on some external database. It's built on top of Apache Kafka, and it implements change data capture mechanism using logs. What does it mean? It means first that it captures all changes, including deletes. That's something that some similar tools are not able to do, and there are no pooling delays. So essentially, when the change occurs, it's captured and it's available for replication on a destination database. And we will see how the architecture looks in a couple of minutes. Debezium has a lot of connectors that support multiple databases. We will see how it works with the example of CrateDB and instance of SQL Server. And how it works in general, it just monitors database changes and publish them in a streaming service, in this case, Apache Kafka. And let's see how it works in practice on a simple example, and then we will see how it works in practice with the real demo. So what we are gonna see today, we will see how with Debezium you can capture changes that are actually happening on instance of SQL Server. And for this, we will use Debezium source connector for SQL Server. And all these changes that are captured are going to be written in Apache Kafka as a Kafka topic. And we learned today from Danica what the Kafka topic is and how they actually work in Apache Kafka architecture. And in the end, these changes are going to be replicated to CrateDB with the use of JDBC connector in Kafka Connect streams. So that was the initial idea of today's demo, and I would like to invite Ernan to give us, to show us actually how this works in practice.
Sure. Thank you very much, Maria. Thank you, Danica. Let me share my screen. Perfect. So the idea here is that we have some system that is running, in this case, in SQL Server. We are going to see today. We are going to see this running today with SQL Server, but it could be Oracle, it could be DB2, it could be MySQL, or many of the other source systems that Debezium supports. Let's imagine that this system, for some reason, it cannot run directly on CrateDB, or is not yet running on CrateDB in your environment. You have it running on one of these relational database systems, but you are interested in getting the data over to CrateDB to run analytics, because we know CrateDB is very fast for analytics. It's very easy to manage because of the way indexing works. It provides high availability out of the box, easy scaling. It can allow you to save money on your licensing costs, etc. So the idea is we have the data. The main system is running on one of these systems like SQL Server, but we want to get some of this data and replicate it to CrateDB. And we want that to happen without writing custom code, which will introduce the risk of us making mistakes, of maybe the schema changes. We need to maintain this code, it can break. And we also want to make this without doing batch processing. We don't want to wait for a job that runs at night to synchronize the data. We want the data to be available on CrateDB as soon as possible. So in the live example I'm going to do today, we have a SQL Server instance here, and I also got a CrateDB instance that at the moment is empty. There is nothing on it. It's all a very basic setup, but you could do it with a complex setup on both sides. We got a very simple database here. I call it ERP just to give the idea of the kind of system that you may be looking at having as a source. And there is a test table here, very simple. At the moment it's empty. And this is going to be the table that we are going to replicate today. So like Maria explained, we're going to be doing change data capture. Anything that changes on this source database will be captured, will be streamed to Kafka. We'll go into a Kafka topic. And from there, there will be a sync connector via JDBC, taking advantage that CrateDB is compatible with the Postgres protocol. We will just do a JDBC connection with the Postgres driver, and we will write directly to CrateDB. So the first thing we need to do here is we need to, on the SQL Server side, we need to create an account for Debezium to connect and grant it appropriate permissions. So I'm just going to copy here some code. This very simply will create a login, will assign it the data reader role into this database. For a production setup, you may be looking at a different setup, but this works for the purpose of showing how it works. Next step is we need to enable change data capture. So some of the source database systems supported by Debezium had their own change data capture functionality. And the nice thing about the connectors provided by Debezium is that when the source system has some change data capture capabilities, Debezium builds on top of that. So this is done in an efficient way. In this case, SQL Server has some functionality around this. So we are going to use the built-in functionality. To enable this, you will need appropriate permissions on the SQL Server side. In particular, something to mention, if you are using AWS and a managed instance in AWS, so SQL Server or Node.js, they won't allow you to call this store procedure directly, but there is an equivalent store procedure that they provide to achieve the same result. So we are going to execute all this as it is. We are enabling the change data capture feature on this database, and we are telling it to look at the changes on this table. Sorry, it takes a few seconds because it's all running on my laptop. Here it's all live, by the way. So if you see anything failing, it's just the effect of it running live. So okay, that's done. Perfect. And now let's go to the CrateDB side. We similarly to what we did on SQL Server, we need to create a login for Debezium to connect to CrateDB and write the data. So we are going to create a user also on this side, and we are going to give it some permissions. And again, I'm giving permissions on an entire schema, but for a production setup, you could restrict these permissions further. And we need to create a table with the same schema of the source table. We need something that is quite important. We need a primary key, matching the primary key in the source system. Essentially, you use the same schema. Just a quick note on this. On the source system, we got a default constraint. CrateDB, of course, also supports default constraints, but in this case, we want to get the value from the source system, so I don't put a default constraint on this side. Let's just create this table. The table is there now. Table test, 0 records. Perfect. I pressed it on. There we go. So 0 records. Perfect. Now I got an Ubuntu server machine here. And the first thing I need to do is I need a Kafka infrastructure. If you are watching this webinar, maybe you already have Kafka infrastructure on your environment. But here we are going to do a very, very trivial setup with just a few containers. So the first thing we need is a Zookeeper container. Zookeeper is a distributed system that is at the base of Kafka. And we're going to just start out with a container image. Here I am running this container on this console, not even in detach mode, just for you to see what's going on in the logs. But of course, in reality, you may have a distributed system. It will be very different. But let's just get this started. The steps are exactly the same, even if the environment has a lot of nodes for every component. So I think that is running now. Let's open another session. And now we need to start Kafka itself. So we are going to start another container, and we are going to connect it to the Zookeeper container. It will take a few seconds. All this is because I don't have Kafka infrastructure already in place, but and I wanted to show you in case you are testing this and you want to see how to do it from scratch, but we haven't got to the core of code to establish the link yet. It's just the preparation work. Right? So perfect. So I think we got Kafka running now. Next thing, we need to create a couple of Kafka topics to support the process. To do this, I need some command lines utilities that are available inside the container. So I'm just going to go inside the container. So docker exec, I'm going into bash inside the container, and I will be running 2 commands here to create 2 topics that we need for this setup. Don't worry about the details. We will share with you a link to an article that has all this code, so you will be able to replicate this on your own. If you are interested, I am doing a very basic setup here, just to show how it works. If you want to go live in production, you may want to look at things like persistence and security, but here I just want to show that it works, that the data flows end to end. So let's get the topics created. So that's one, and let's create another one. Awesome. Yes, perfect. Great, that's done. We come out from the container. And the next thing we need to do is we need to get the Debezium. We are going to be running Debezium also as a container, but we need to customize the base image, adding 2 things to it. One is the Postgres driver, the standard Postgres driver, and also this JDBC sync connector that Danica's company Confluent has developed. You can download this from here. I have that downloaded on this machine already. It's there. So I'm going to create this custom image. The first thing I will do is I will create a folder here, and let's call it custom Docker image. I'm going to go inside and I am going to create a folder to store the connector. So let's call this M73. Now let's go inside the folder and let's unzip the zip file from before. At least one more level below. Let's see. We need a minus check. Okay. Okay. And now let's create a Docker file, manifest file. We are going to put a few commands in here for Docker to build the image. So we're going to start from the base Debezium connect image. Then we need to copy the .7.3 to /Kafka /connect. Yeah, looks right. And then we also need, so that will take care of the JDBC sync connector, and then we need the Postgres driver, and we are going to tell it to download it directly from the Postgres website. And we need a couple of commands here to finalize this manifest file. There we go. Let's see if this builds. And I will do all this CrateDB connect is. And build first the CrateDB connect. Build, sorry, build instead of build. Build first. And then they go direct file. Sorry, it's that I named the file incorrectly. File for There we go. Sorry for the confusion, but that shows it's live. And we'll just take us a few seconds to do this. Perfect. So now we got this custom image available, and we are going to start it. And we are going to use this docker run command. Here we are doing a couple of things. We are telling it where Kafka is and which topics to use in Kafka. We are, yeah, so that's, go ahead with that. Just a few more seconds to the starting. Okay, when that finishes starting, we can move on to the next step. The next step, now this is the crucial part where we are going to do the configuration to connect both to the source and to the destination. So this is very simple, very simple. We are just going to create two JSON files. So let's first create a file called connector.json. And this file is going to have all the configuration to connect to the source, to SQL Server. So let me just copy this definition here. In here, we are telling it that we want to go to the ERP database, the DBO TBL test table. We are giving it the password, the username to use, where to find the SQL Server instance, and there are a few other settings, but you see that overall it's very simple, and if you will have more tables to replicate, it will all be just a few more lines of configuration. There is it's not like you are writing a script here. It's just giving it some basic configuration settings. So let's save that and let's deploy that. So to deploy it, we will do a call to the web service running on port 8083 in this case, and we just pass the connector JSON file. Sorry, it's not running. It's not running yet. Now Kafka Connect started as well. It's all very slow because of my laptop here and Zoom and everything. So it was still starting, and no, we didn't. It was just timing thing. We didn't do anything wrong yet. I think now it's going to get deployed very quickly. Just wait. Yeah, now it's looking good. And now very similar thing. We are going to create another JSON file. Let's call this destination connector.json. And again, I'm going to copy this template here. So we're specifying where to find CrateDB, username and password, the topic that it should be reading, the changes that are getting streamed from. All very simple. What was the primary key we are for the table, and nothing else really. So we just save this and we deploy it in the same way that we did before. That's good. That means we got deployed. And that's it. That's the whole configuration that you need to do. It looked a bit involved because I had to start Kafka and everything, but if you think about it, I just created a simple JSON with the connection details for SQL Server, a simple JSON with the connection details for CrateDB, and I enable change data capture on the source SQL Server database. And now let's go to SQL Server and let's try to do some changes. So we say we have the table here that at the moment is empty. Let's insert a record in there. For instance, let's do something like this. So now the table has a record in there, and there is no schedule here. It's as soon as possible things get streamed. So let's see if things were fast enough. If I rerun this select here, not yet. Let's wait a second. There we go. So the record has arrived already. I need to insist that this is my laptop running all the virtual machines for everything, right? For Zookeeper, Kafka, SQL Server, Debezium, and everything. But in a real scenario, this will be really fast. Let me show you that this really works also for updates. Let's run an update here. So we did an update on the SQL Server side, updated successfully. Let's look on the CrateDB side. There we go. The update is already has already flown the whole way and is already in CrateDB. And that's really it. Let me just maybe go back to the presentation. We got one slide on the benefits. So this has allowed you to take your data from a system that you cannot, that you need to have running on one of these legacy systems, all the way to CrateDB without writing any custom code, getting the changes through as soon as possible. So without a schedule, without having to wait, like Danica say, days, months for something to run and synchronize the data up. And now you can enjoy the benefits of CrateDB, like availability, easy scaling, very fast aggregations, lots of features. So we hope you find this useful.
Thanks, Ernan, for recapping your demo and highlighting the general benefits of the approach. We started getting some questions, and Danica was nice enough to answer some of them. I would answer live those that are still in the open box of the Q&A form. So the question we got regarding CrateDB, what kind of data can be stored in CrateDB? So we, in general, mentioned at the very beginning that CrateDB is multimodal database. It could be used for storing different types of data, starting from some simple relational tables, but you can also store blob data, more complex data such as nested objects and arrays. You can also store geospatial data, more or less all of the data of the types such as int or text. And yeah, it can be used for a variety of use cases such as, I don't know, time series, Internet of Things, monitoring, application backend. In general, there are a lot of interesting use cases for CrateDB. It can be considered as a general purpose distributed database. So Danica, how do you feel about maybe going through some of the questions that you already answered, just for other people to recap? There was one question about what is the really benefit of the Debezium CDC approach compared to traditional ETL methods?
Yeah, absolutely. So as I said in the response, so yeah, a lot of connectors, not just Debezium, could totally be set up in a traditional way, either using regular ETL methods or just setting up consumers and manually managing, bringing that data in. The benefit of having it as a Kafka connector within the Kafka Connect ecosystem, there's a couple of them. And the biggest one is that it's a managed framework, right? It's not just running launching another job that you have to manage. Once you run it on the Kafka Connect sort of cluster, you get scalability of that job. So if you have multiple tables that you're reading from and monitoring, you can actually parallelize that, the processing of bringing that data in and managing those events. You get retriability built in as well. So the Kafka Connect framework is going to help balance that and scale that for you. Okay. Some other ETL methods might have that built in as well. So the next benefit I think is important, and that is the data's in Kafka. Okay. So yes, this was just one use case of using Kafka sort of as an intermediary stage to move the data into CrateDB, but that might not be your only use case, right? There might be other applications that could be taking advantage of these deltas that you're pulling out of your database. And then in that case, you can set up sort of infinite retention on that Kafka topic. This sort of plays into another open question that I was about to answer. So that having that infinite retention means that other applications can come in maybe months later and tap into all of those deltas and rebuild that state for their particular use case. So that's beneficial. And I see that a lot for many Kafka use cases, right? The real benefit lies in not just having an A to B sort of pipeline, but being able to fan out and have other applications take advantage of that same data and make sure, well, at the same time, making sure that the integrity of that data is maintained. You have a golden copy of it in Kafka for people to use. And then also with Debezium, as a final benefit is that it's way easier to get the deltas because it is reading from the underlying logs of the database. So there's a lot that you get out of it.
Thanks. And there is one question from Joseph. I think it's a perfect question for you.
Yeah.
How do you handle for a new player into the stream? Imagine you have been streaming something to Kafka topic, some table, and there is X number of consumers that have been consuming this topic. A month has passed, retention period for Kafka message is long gone. Now there is a new consumer that wish to consume the message. How do you do that? How does new consumer get to the start state before ready to consume from the Kafka topic?
Yeah, so I kind of touched on it in my last response, and what I would recommend in that case is, and what I've seen with a lot of use cases that are using CDC data from databases, is to maintain infinite retention on that Kafka topic. And so in this case, any new consumers for whatever number of time that you need to have that information there can come in and build up that full state that you would see in that database from those deltas. So Debezium is only one way to get deltas from databases, especially with Kafka Connect. You can also just use the JDBC connector, which is flexible in that you don't need to do just the deltas. You can actually get the actual rows based on updates, like the full piece of data. And in that case, that might be better because then you could set up a compact topic per key on the database row, and then you don't have to set up the infinite retention. So there's different ways that you can handle this depending on what your needs are and what the overall goal is for the downstream systems, but it is flexible. But in your case that you just mentioned here, you should do infinite retention.
And there was also a question about the difference between Kafka Connect and Debezium Connect. And Kafka Connect has certain set of connectors as well as Debezium Connect. Do you know what the difference is coming from?
So I personally, as I respond, I'm not really familiar with the phrase Debezium Connect. So every time I have worked with Debezium, it has been within the context of Kafka Connect. And based on what I have heard, you almost certainly will deploy Debezium with Kafka Connect. There is a way to take Debezium and embed it into Java applications. But I'm not sure, I've never heard it referred to as Debezium Connect. So whoever asked this question, if you could chime in and clarify, that would be really great, because I'm a little lost on that phrasing.
Yeah.
What I would add to that is, is that the Debezium, what it brings on top of Kafka Connect is the connectors that know about the change data capture functionality on each of the source systems. So like you got this SQL Server connector that knows about what SQL Server can already do about change data capture, and it builds on top of that. But it relies on Kafka connectors.
Okay,
on the previous question, on the previous question about the what to do if the retention period has already passed. It depends. You have lots of options, like Danica said. It's all very flexible, but of course, it depends on what you are trying to do. But if you have some kind of a snapshot of the source system, of course, you can also initialize your CrateDB database with the data from this snapshot and then catch up from that point in time. So it all needs to be seen in the context of what you are trying to do exactly. But
exactly,
yeah,
cases, you have options.
Yeah, definitely.
Yeah.
And there is one follow-up question on this one. Do you want to finish the previous one, or can we move to the next one?
I'll answer the follow-up from Joseph.
Yes, exactly.
That infinite retention. Yes, infinite retention hypothetically will take up infinite space. So you really need to know up front, like as we just sort of said, like you have to really think about your use case and plan ahead. I would not suggest doing setting up infinite retention for fun if you don't actually know how much data long-term you're going to keep. And as we just said, you can get around that with initializing snapshots. And so like if you're taking regular snapshots of your database, you can sort of initialize another topic with that and have that as a starting point for your applications so that you can limit what you actually need to store on the deltas topic. But yes, infinite retention and infinite storage, always a concern and something you need to think about. In this case with Kafka, a lot of folks who need that will use tiered storage to sort of offload your storage off of the local broker and move it to some cheaper storage for long term.
Thanks. There is again one question regarding moving data from DB. If I have a source connector that is bringing data from a DB and I want the source connector to start again from scratch and bring all the data from the table, is it simple and safe to reset the offset using the connect offset topic? Can someone help me with this one?
Yes, you can do that. There's a couple years ago, I spent much of my time working with source connectors and dealing with exactly this situation. And so yes, in that case, what you would want to do is reset the offset for within Connect, and then also basically erase the topic that you're putting the data into. That's more or less what you would have to do. And that's something that you would have to do manually. You would have to set a tombstone offset to that particular Connect offset, that key in that topic, and then restart it and hope that everything works right. They are the people that work on Kafka Connect right now in the open source community. They are working to make this easier. And there have been some KIPs, some Kafka improvement proposals that they are currently working on to add this functionality to sort of the admin capabilities of Connect, like on the CLI, so that you don't have to do, yeah, it's still manual, but at least it's built into the CLI, so you don't have to like manually send the offsets directly to the keys. So look forward to that in the next couple of months. They'll be releasing that to make your life a lot easier.
We have 2 more questions. Wow, a lot of questions today. How does Debezium handle data consistency in case of failures or network disruptions?
Yes, maybe I can take that one. So,
yeah, go.
So is all the changes are logged either on the source system or Debezium's on log or the topic in Kafka. So in case of any failures, everything is retried. It's all designed to be resilient. It's a distributed system. It's designed with failures in mind. So that's not a problem.
Yeah, and I really just want to add to that and drive that home is that every stage of this pipeline has extra checks built in to make sure that you don't have any hiccups in that, right? Like the database logs are always there. If your database is working properly, you're going to have those commit logs underlying, containing all those deltas, the updates, the deletes. And so even if connect goes down, when it comes back up, it's going to know where it left off, right? Because connect is based on top of Kafka, and Kafka also has checks in place to make sure that it doesn't lose its spot. So at every stage, you do have some added failover and fault tolerance.
There is a next question from Joseph. For sync connector, it would be fine for simple use case that the sync destination database mimics similar schema to source database. But if schema is different, we can't quite just deploy the sync connector. It will usually require complex transformation, lookup, and others before getting into the destination database. How would you recommend to do this in this case?
I can comment on that. Maybe Danica wants to add as well. What you get from Debezium is you get an entry in the topic where you have all the old values in the record and the new values. And what I did in my configuration file was very simply just take the new values. But you can plug in a transform step in there and do any kind of computations that you want with all the values that are available in that context. If you need information from outside that context, then you need something a bit more complex. You could still leverage Debezium, the Kafka, and everything, but maybe you are looking at some kind of service that will consume this together with something else and then write somewhere else. And only have that thing, that data is already transformed, flowing into CrateDB. But very simply, if you can do your transformation with information that is in the context of what Debezium writes, you can plug a transformation directly into the sync, into the step there.
And just so that everyone is aware, that is something that is built into the Kafka Connect framework. So that's another benefit that you get from that, is that for every source connector that you set up, you can set up any number of SMTs, they're called single message transforms, that, as he said, they rely only on the information that is currently in that message that is pulled from the source, and that is run and executed on the individual messages before they're written to Kafka. And then on the sync side of things, the same thing. You have SMTs, any number of them that you can run on the data once it's pulled from Kafka and before it actually goes into the sync system. And so there's a bunch of pre-made ones that you can already take advantage of. I believe there are ones that you can actually say, for a schema that has multiple objects in it, you can pull just one and bring it to the top level and effectively do what he was saying. But if you need something more complex than that, if you need to make some sort of third-party API call to resolve that information, you can also write a custom SMT. I've done that. I don't really recommend it. It might not be the best thing to do because again, within the Kafka Connect framework is great for, it's just great. It's pretty robust, but as soon as you start adding some third-party calls in there, it can get kind of weird as far as retriability. But you can totally build a custom SMT to make that work. If you do need to make it even more complex than that, still within Kafka, you can set up maybe Kafka streams and join with the additional data sources to resolve that information or make those changes. And it's going to have a source in Kafka, write it to Kafka as well. And then from there, you can have your sync write it to wherever you need to.
And the final question, are there any performance considerations or limitations to keep in mind with using Debezium with CrateDB? And maybe we can mention maybe something regarding the data schema or amount of data you want to replicate. How does Debezium handle this?
Yes, of course. So usual considerations around network bandwidth, number of columns, if the amount of changes that are coming through the system, you may need to do a little bit of a sizing exercise there to see to make sure that you got the right infrastructure for Kafka, the right infrastructure for every component in this architecture. But for simple tables with not that many changes, we saw it here with extremely limited resources, how it was still able to handle it in a matter of seconds. So, but if you had a heavy flow of data, then yes, you will need to consider what tables you are replicating, what columns, and you wouldn't just say I want everything, and yeah, you will be looking in detail at what you choose to replicate.
Thanks. That was the last question. If you have any further questions, you are free to actually join our CrateDB community and to ask further questions there. We prepared a lot of interesting tutorials and references if you want to learn more about CrateDB in general, how to use CrateDB with Kafka, Kafka Connect, and Debezium. And CrateDB is an open source project, so like I would like to invite you to give us a star if you like it. We believe it's an awesome project, and yeah, so like have this in mind. I would also like to mention that we have a managed service for CrateDB, CrateDB Cloud. You can very easily deploy your first simple cluster that is going to be free forever without leaving any payment information. So you can start doing some queries on CrateDB, exploring its capabilities for free without the need to make any payment information. But if you would like to try some more complex configurations and have more complex use case, we also give you $200 free credits towards different operations. So let us also know how you find CrateDB Cloud. But if you have further questions, except joining our community, you can also join us in the next office hour session, which is taking place on August 2nd at 3 p.m. Central European time. And this is actually a great opportunity to talk to our engineers in a more informal setting and share your use case, ask any questions you might have about CrateDB and general CrateDB ecosystem. So that was it for me. I would like to thank Danica especially, but also Hernan for joining us today and providing so many insightful knowledge to everybody. I really hope you enjoyed. There will be a recording after this webinar that you can watch again, but just be free to contact us if you have any further questions. And yeah, thanks again. Hopefully see you all soon. Bye-bye.
Thank you.
Thank you.